Okay, hello and good evening, everyone, for what should be, or hopefully will be, an exciting night of the Artemis launch. You can see I am streaming from a different location this time around. I'm streaming from home. So I do apologize if you see a black cat run in the background at any point. This is a time of night where he's very active, so you can look out for him perhaps throughout the stream. So my name is Jeremy, for anyone new to the Kopernik Observatory YouTube channel, and I am traditionally Kopernik's live stream astronomer, and we focus on observing live streams a lot of the time, but we are branching out to more reaction type streams with our Kopernik reactions. Tonight's reaction is going to be on Artemis I, the potential launch of Artemis I. Originally scheduled for back in August, I can't remember exactly what day. It has been delayed a few times, and of course a launch window to the moon, even though it does come around every once a month. If you lose that window, then you'll have to wait. So tonight, though, there is a launch window from 1 to 3 o'clock in the morning, roughly, and that's what we're going to be on the lookout for. So join us as we tune into NASA's live stream. I also have a bit of a some slides, a presentation of my own that we'll get through some, especially as we head towards 1 o'clock. But to start the stream off, I would like to jump us into the NASA stream just to see what they're up to over there. Maybe we'll get an update. Last I heard, we're saying if they were to launch right now, if the window is right now, it would be a no-go because they're having some radar issues, and I believe they've narrowed it down to a Ethernet switch. So if they can get that replaced and all figured out, when 1 o'clock and maybe 2 or 3 o'clock come around, it'll be in a good position to launch. There was also a leak earlier, and that was another potential area where it could have scrubbed if that window was happening right now, if the launch window was happening now. But they got that repaired. So that freed up a potential issue that could have cropped up from 1 to 3 o'clock. So definitely a early morning stream again here, like the lunar eclipse. We had a fun time during that stream, and we're back at it for another moon-related event with the Artemis mission. So let's jump into the NASA live stream here and see what's going on. I'm going to bring us over to that slide. Here we go. Oh, and it's muted, so let me unmute that so we can hear them.
Drill, it's going to be a celebrity question, so let's take that.
Hey guys, I'm Jack Black, and I'm super excited for the Artemis I launch today. I was part of a little movie called Apollo 10 and a Half, A Space-Age Childhood, and I have a few burning queries. Question the first. How is Artemis different than Apollo?
Artemis is different than Apollo because we're returning to the moon, but this time we're going to stay. So rather than a short visit where we can do some amazing science, but it was pretty limited by these short visits, kind of a small area of the moon, we're going to the South Pole and we're going to learn how to live there long term. So we're going to be building habitats, we're going to have rovers, we're going to have all of this infrastructure on the moon supporting scientific discovery, but also that next big step to Mars.
I love seeing celebrities also take part and ask questions because it really shows that this is something that's captivating a lot of people. So that was really fun to see Jack Black. Also, query the first. That was funny.
That was good. That's good. I think that was the second celebrity that showed up during this stream. They also had, I think, Chris Evans earlier as well ask a question. So it is kind of cool to see that interaction play out. It definitely gets more eyes on big space exploration events like this. So that is awesome to see. And that was a great question as well. How does it compare to Apollo? And of course, the big part with this one, whereas Apollo was of course focused on bringing the first person to the moon and landing them on the surface and having them explore, there was no baked-in transition plan to get us to Mars. Whereas with Artemis, that is a heavy focus. They are thinking about the future and going to the moon first as almost a way station on our journey to Mars. So we have to go back to the moon before we venture out to the red planet. So I like that question a lot. It was very cool to see. So let's see, I'm also studying the captions here, but we can turn the audio back on for a second. Of course, like the purpose of this stream is a little bit of reactions from us here at Kopernik. You can of course tune into this live stream also. If you prefer to just tune in directly through NASA. But this platform is an opportunity to chat with us here at Kopernik and ask some questions that I might have the answers to. I did some studying for this for sure, and we of course talk about this a lot at Kopernik during our programs. So I'll be able to answer some questions, though definitely not the most technical ones. That's what the rocket scientists are for. And hopefully some of those more in-depth questions get answered in NASA's live stream. So what are we doing with time? We're heading towards 12:30. My cat is currently trying to get into our cupboards. Like I said, he's very energetic at the moment at this time of night. Oh, hello, Stacy. I'm looking at the chat while we chat about Artemis here too, so I'll occasionally look down at it. I also saw something from Lauren asking that they see the flight is delayed with a new window of 104 to 304. So, oh yeah, that wasn't a delay. That is the original launch window. Is that 2-hour launch window from 104 to 304 a.m. But we started the stream at 12 a.m. and I realized, posting that thumbnail, it might have been confusing. That we said, Artemis 1 is launching at 12 a.m. It really isn't. It's launching potentially from 1 to 3 a.m. So the reason I put 12 a.m. is because there's a lot to talk about before we get to the main launch event. So that's what we can spend time doing here as we head towards the launch window. And like I said, I do have a little presentation with some videos that can help us understand what Artemis is all about. So yeah, welcome everyone to the stream. Happy to have you here. I think we have over 20 viewers at the moment. So it's great to have everyone at this late hour tuning in. So let's turn the audio back on here for NASA's stream and hear what they're talking about.
To resume terminal count, the launch team will assess what work needs to be done, how that syncs up with the range getting back online with their equipment, and then we should have a new T0 for you soon. That's the latest from Firing Room 1 here at the Kennedy Space Center. Megan, back to you.
So things are obviously still very dynamic. We're going to come back to Daryl as much as possible. Now, to understand where we are going, we have to know where we have been. To do that, we spoke to some of the special few who walked on the moon and those who sent them.
We choose to go to the moon in this...
So it does sound like they are having some launch difficulties still. It no longer looks like they're counting down as they were before. So it sounds like they'll resume the T-minus clock as soon as they've gauged what's going on. Now, I didn't hear the initial problem there. Like I said, they've had leaking issues, as they've had with previous launch attempts, though in theory that was repaired, and they were refueling the hydrogen tank, I think, was the problem. And they also had an issue with a radar dish, which they thought was an Ethernet switch, and they were working to replace that and get that back online. But at this point, it sounds like there are enough problems that they can't commit to the 104 launch, which was what they were counting down to originally. So yeah, we'll see what happens here. I'm happy to be here with you all and watch this exciting event. If it doesn't launch tonight, during that launch window, if they do cancel it again, we will run another stream like this because we want to see this happen and we want to watch together. So just keep that in mind too. If we don't get the chance to watch it together tonight. I do still think it's worth going through some of my presentation because I have a lot of cool videos in there to show you that focus on a lot of different areas of the return to the moon. And that's the first slide up in the top window there. So it looks like they're going through a retrospective of the space exploration throughout the years from the Apollo era up to now, I'd assume, and the historical context for Artemis. So that's great to see. But since they're not really counting down, we're going to keep this window available, and I'll of course keep chat open. So if you find that that clock has resumed, or if we see that happen, make note of it in the chat. It's a good way to make me alert of it if I'm not paying close enough attention to it. But when we switch to my slideshow, this one, I gotta get used to that. It's flipped for me. This window here is going to be up here. And then my slideshow will come down and go in the big window. So we'll still be able to monitor NASA's stream. All right. Yes, Nicole mentions another recent issue was the Ethernet switch. So yep, that's one of the things that I last heard they were working on. And this last update I missed why they stopped the clock, but it may be for that same reason. All right, we have Sheila tuning in. Hello, Sheila, and Ruth. Hello, everyone. Great to have you here. Okay, so let's switch gears here. Again, we'll continue to monitor NASA's stream, but we're going to switch gears to the slideshow I've put together for our channel. And we call it The Return to the Moon. And again, if you're just tuning in, my name is Jeremy. I am a science educator at Kopernik Observatory and Science Center. And today I'm streaming from my home. So that's what you see in the background behind me. Because it's late at night. I didn't want to go up to Kopernik, especially because we're not doing an observing live stream. I think this works just as well. I think this is the kind of event, you get comfy and we hope for the best that this rocket will take off. And we look forward to that. Of course, even if it doesn't, keep in mind that this is the first launch of SLS and Orion of the Artemis system. And they need this to go well because it's the rocket that will be used for Artemis 2 and 3. So they need this rocket to work. They want to make sure it's safe. They want to make sure it does launch and complete its full 42-day mission. So they're not going to risk the rocket at all during this testing phase of the Artemis program. So keep that in mind as we think about why it hasn't launched yet. That's the reason. They're being very careful about launching this particular rocket. Hello Montambale, welcome to the stream. Glad to have you here. We have a good group of people tuning in. So let's go through my slideshow here, talking about the Artemis program and our return to the moon. And we'll watch the countdown clock you can see just in that upper left corner of the window above me. So if that starts ticking again, that will tell us that they have a new time. It's not going to launch at exactly 1:04 a.m., but they've rescheduled for some time in that window. And if it doesn't start ticking, then it means that probably isn't going to launch tonight. So we'll look out for that countdown clock up there. All right. So the return to the moon. Now this picture here we'll discuss a little bit later into this presentation, and I've also designed this so that we can pause this at any moment. So no worries there. In fact, it looks like they're showing the SLS, the different parts of the SLS in the live stream right now, and we'll cover some of that, talking about the boosters, the different stages of the SLS system. But this is more forward-thinking as to what the lander will look like. And you may recognize it if you follow the different companies that participate in not just NASA's programs, but their own programs as well. So let's carry on. There's a full image of the possible lunar lander for the Artemis program for Artemis 3. Okay, so Artemis, here's the logo for Artemis. And I really like this one. You can see there's some easy things that you can point out here. Artemis is designed to be a lunar mission. So it echoes back to the Apollo era logo. You have the Earth down here, launching from the Earth and to the moon. And I like this red pathway too, kind of showing you that this is the transition to bring us to Mars, to bring humans to Mars for the first time. So you got going from the Earth to the moon as a pathway to Mars. I really like that. And of course, Artemis, the Artemis name, also harkens to the nature of the program that expands inclusivity. So this will be the first time a woman is launched to the moon and lands on the surface, and the first time a person of color is as well. So I think that's a very critical part of this program, is that level of inclusivity. And there are some great potential candidates already lined up. In fact, there's a chance that one of our local astronauts, Jeanette Epps, who grew up in Syracuse, New York. Kopernik is based in Vestal, New York, and she grew up about an hour away from, a little over an hour, north of Vestal, New York. So pretty close by to where we are. And she is potentially a candidate for the Artemis program. So that will be very exciting if that pans out. So yeah, lots of exciting aspects to the Artemis program. And I love this logo. It really does convey a lot of information all at once. All right, that's Artemis. Now, throughout the presentation here, we're going to talk about different aspects of the Artemis mission. There's 3 parts to it. There's Artemis 1, 2, and 3 that are planned so far. And we'll talk about each of those. Artemis 1 is potentially launching tonight. And as we go further through the show here, we'll talk about the Space Launch System, Orion, Lunar Gateway. These are all components to the Artemis program and how it will be successful. And we might even venture, if we have enough time, we might venture to discuss some new technologies that are going to be implemented, and how they've had to develop those to make both traveling to the moon and Mars and even beyond a greater possibility to see that happen in the future. So we'll cover through here, and I have a lot of neat videos from NASA to show you. So this is Artemis 1, and it says one of the slogans for Artemis is "We are going." We're going to the moon. So this says, I do have the date in this one. So Artemis 1, August 29th was the original launch date, August 29th of this year. And now I should say original. It might have even had an earlier one in the earlier stages. They might have been thinking, 2021 sometime in the original planning for Artemis 1. But it did get either way. It pushed out to August 29th. And they had a big event for that, and sadly, they just ran into too many issues, and they had to scrub it. They scrubbed that launch. And now here we are. They did make a couple more attempts, I think, in September. And then October, they had to worry about Crew Dragon, getting those astronauts up to the space station. And now we're into November. So we'll keep our fingers crossed that Artemis goes tonight. All right, so Artemis 1, it will be a 42-day uncrewed flight test of the Space Launch System and the Orion spacecraft around the moon. So it's 42 days. It's a lengthy mission. Not even the astronauts, they might not even be on the moon that long for Artemis 3. But for Artemis 1, this sticks around for a while because it's purely automated. It's there's no humans on board. It's just in fact, it's mostly Orion with some cube satellites tagging along as well. So it's a test of the Space Launch System. It's a test of the Orion spacecraft, and they did implement some science missions as well with the cube satellites. And I'm going to talk about one example coming up here about the cube sats that are going along with Artemis 1. So let's take a look at that. I think that's the next slide here. Oh, here we go. This is, before we do that, this is the Artemis I mission patch, which I really do like the aesthetics that they're going with here. Again, this one is more focused on the Space Launch System with the Orion capsule as the payload on top. And again, looking at those the blue and red pathways around the moon. So using the similar elements for the Artemis I mission patch. So that's a neat one too. And
you support a quick remote check at this time. Certainly can.
Before it gets too loud on us, let me talk about this ice cube here first, and then we'll go back and watch that video of it's kind of an overview of that 42-day mission. Just some animations put together for it. But yeah, one of the science missions that is aboard Artemis I is IceCube. It's a cube satellite, and these cube satellites are really not that big. They're just small satellites with a lot of equipment on board, but miniaturized equipment. Because for the type of missions that they're doing, they don't need a lot. Those solar panels you see on either side of of IceCube there, they fold up, they collapse. So while they look like they're pretty big, even those fold up into a nice small package. And IceCube is one of 10 cube satellites for Artemis, and it's designed to hunt for water on the moon, especially around the southern region, the south pole of the moon, because that is where we're going to send astronauts during Artemis III. They will visit the south pole of the moon, and we know water exists there. There's ice water. Oh, you might hear my cat. We'll see if he hops up and visits the stream here. We know water exists at the South Pole. It's ice water, and it's been there for billions of years. And it's just been preserved at that South Pole. So we can use that water. It's of great interest, not just as a general resource for humans visiting the moon, and we'll also want to hopefully find some good water resources on Mars. It's also for truly it's primarily for making rocket fuel, because with rocket fuel, liquid rocket fuel, you just need hydrogen and oxygen. And in fact, Artemis I, the Space Launch System, uses its core engine, its core stage uses hydrogen and oxygen as its fuel source. The hydrogen is the fuel, the oxygen is the oxidizer. And when you combine them, you get a lot of energy. And that's what we're going to see today. And when it launches, it'll be burning that fuel. So with water, you just have to split the hydrogen from the oxygen. And that's relatively low cost to do, and you can do it with electricity. So bring some solar panels along, break up that water, and you can create rocket fuel. That's why it's so important to find those sources of water on these worlds that we're going to be exploring, because if you don't have to bring extra rocket fuel with you, that bodes very well for future missions. You don't have to worry about that extra weight of fuel that you're not going to expend until you leave. You can just make it there. So that's fantastic. And again, as we think about the moon being a way station for Mars, that's opens up other opportunities as well. So let's go back to that video here and we'll watch it together. The countdown clock still has not started, so we'll watch this here. Oh, no, we gotta go back one more. That's just IceCube. Try this. Artemis I, and we'll watch the overview.
You support a quick remote check at this time. Certainly can, roll some tickets.
Okay, here it comes.
Traffic with a test 1.
Crew is go. SLS is go for core stage engine start.
Liftoff confirmed.
Copy liftoff.
All right. So that's the Artemis 1 mission, how it will play out, but of course much quicker. That will play out over 42 days. We got to watch the launch, its entry into space above the Earth, its insertion into orbit around the moon, and then its return to Earth and its landing in the ocean. So that harkens back to the Apollo era as well, right? That is how those capsules, in fact, most capsule designs end up landing in the ocean. Okay, so let's carry on here. Looking at the countdown clock on NASA's stream, it's still static. They have not restarted T-minus countdown. So they are still working on some issue with the rocket itself. Okay, and then again, that doesn't mean it won't launch tonight, but they're working on some issue that makes it so they can't guarantee a countdown to a specific time. So that's why the countdown is on hold. Looking in the chat here, I saw some things pop up while we were watching that video. Oh, yep, hello, Mike. Welcome to the stream, and I'm happy to do it. I really want to watch this launch too, and I think it makes sense. We have such a great group of people tuning into our streams that we can all watch this together. And then Matambali says cat commentary too. Yep, he is a very vocal cat, so I'm sure you will hear from him again as we watch our Artemis live stream. All right, so now let's carry on to Artemis II. And Artemis II is potentially going to launch in 2024. Now, there have been enough delays in Artemis I that they might not be able to hit that 2024 date. Now, I'm not sure. I mean, obviously that mission's being worked on as they wait for Artemis I to launch. But this all does hinge on this rocket working as expected, the Orion capsule functioning as expected, and they'll take a lot of the data from Artemis 1 and, of course, apply it to Artemis 2 and 3. So they really need to get this rocket going before they can start really applying the data they want to those missions. So Artemis 2 is going to be a crewed flight test. So this will have astronauts on board. And it's a crewed flight test of the Space Launch System and Orion, and it will travel to the moon, but it won't land on the surface. So very similar to the Apollo era. Before Apollo 11, they were sending out those missions to go in orbit around the moon. They didn't make it to the surface. Again, you test this step by step. Both the capsule, the rocket, and prepare the astronauts on board steadily for this new age of lunar missions. All right. So that's Artemis 2. And then I put Artemis 3 Plus here because there is potential for future Artemis missions. Just like Apollo, they may add more as time goes on. And this is looking 2025 and beyond. Again, this schedule can potentially slip. This is just current deadline, but they need to see what happens with Artemis 1 and then 2. And then finally move on to the lunar landing, and that's the purpose of Artemis 3 and beyond, is that you will have potentially a regular cadence of Artemis missions with crew on and around the moon. And that is an important point with around the moon, because it's not just going to be landing on the surface. You're going to have science missions being performed on a new space station as well. And that's what we're going to look forward to with the Lunar Gateway. Oh, they're showing a moon rock. Let me skip to that. Let's see, here we go. They're showing a moon rock on the NASA stream. Now, what's cool is I guarantee isn't the one we get. Maybe it is, who knows? But you can see the case in the back there. I can't quite read the title, the name of the rock, but there are a lot of these, so I guarantee it's not the one we often get. But yeah, they do loan out lunar samples to science centers and observatories and museums around the country, and you can actually look at the sample. We've gotten them at Kopernik before. We have a nice display for it. You can look at the lunar sample up close. It's encased in a sort of a plexiglass pyramid, and there's a really nice display case for it explaining who picked it up. We've gotten Apollo 16 and lunar samples in the past, and it's always just incredible to consider where that rock came from, not just during the Apollo era, but on the moon too. It was just sitting there until some human came along and picked it up and brought it back to our home. So really, really cool example of some outreach that NASA does with material from the Apollo era. So that was kind of cool to see. Okay, let's bounce back here. So that's Artemis 3 and beyond with that regular cadence of Artemis missions. Okay, so again, off to the right-hand side of this screen, this is a modified SpaceX Starship. And of course, it's just a concept, but that is a potential design for the lunar lander. Now, SpaceX actually did win the contract for the lunar lander, and that is currently underway, especially as spaceship from SpaceX develops, which it has seen some success in the recent months. So we'll look forward to how that lunar lander works out. You can see at this concept level, it's huge, much bigger than the lunar lander during the Apollo era. You can see the astronauts down here and the lunar rover as well. So that'll be exciting if it ends up being this large. Of course, that means you could potentially take more with you. It has a greater payload, and the landing of the Starship as well is also very compelling if they do intend for this lander to land in a similar way. So it's using that technology that's been developed through other companies and applying it to NASA missions. I think there is a stronger commercial presence at NASA, especially with the SpaceX program for the missions to the International Space Station now, the crewed missions with the Dragon capsule. So it's great to see that sharing of information between government organizations and private companies as well. Okay, so let's carry on here. And here we have a little bit of an Artemis.
Between 1968 and 1972.
It goes a little bit too fast. Let's go back. So I'm going to cover the another Artemis overview here that gives some historical context as well as some descriptions on the different parts of the mission. Now this is more focused on the overall goal of Artemis 3 and getting astronauts back to the moon. So let's bring that back here. Watch that together.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the moon. Approaching the moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit, and once again to sling the spacecraft around the moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our moon and prove that together we are ready to go beyond.
All right, so yeah, definitely a very inspiring video there, giving us a nice overview of how this mission is designed to play out and its overall goal of bringing us back into a state of human space exploration beyond low Earth orbit, which is where we've kind of been stuck since the Apollo era. So, and of course, there's been a lot of advancements that have come from low Earth orbit human exploration of space, especially on the space station. But now we do want to look beyond that because we've learned a lot there about how the human body handles long-term space exploration. And now it's time to go beyond and potentially go to Mars in the next decade or two. So yeah, really nice video there from NASA. By the way, all of these resources I'm showing you, except for one, I think, are NASA sourced. So they're things that you can go seek out as well. And that's a big role that we want to play at Kopernik, is to be a venue to seek out NASA resources and learn about some of these topics. Yeah, they mentioned the different parts of Artemis. You have the Space Launch System, you have the Orion capsule, you have Lunar Gateway, and this is the Space Launch System. And they covered some of these parts earlier. So you have the upper stage, and the upper stage is what's housing the service module, the Orion space capsule, and the launch abort system. So that's all housed in mostly that white section at the top of the rocket here, and a little bit down into the orange section. And then the orange colored part of the rocket is the core stage, and that's a liquid fuel stage. Again, we talked earlier about how you have the liquid fuel, which is made up of hydrogen, and then you have the oxidizer, which is oxygen. And when you combine these two, you get a ton of energy. So that's the liquid stage, and that has, according to this, 730,000 gallons of liquid fuel in it. And then on either side of the rocket, you have solid rocket boosters, and both of those provide more thrust than 14 jumbo jets. So those are among the first parts of the rocket to disconnect, right? Once that fuel's expended, you focus on the core stage, and then the core stage will start to fall off from the upper stage. So then at the very bottom, of course, you have your engine systems, both on the solid rocket boosters and on the core stage of the rocket, and that is providing 2 million pounds of thrust. And all of this comes together to build the first lunar rocket, designed to bring humans to the moon since Saturn V. And of course, you saw in the video the comparison between Saturn V and the SLS. Those are very similar in size. This will be the largest rocket that will have launched since Saturn V. So we are very excited to see this all play out here with the Space Launch System. Now, I noticed they got rid of the countdown, and as we were watching the previous video, I was sort of tuning into their update that they were talking about. I was reading the captions, and it sounds like they are continuing to struggle with a couple of issues, and hopefully we can catch the next overview about what the problem is with the rocket at the moment. They haven't, according to those captions that I read, it hasn't been canceled yet. They are looking for a new T0, which is the launch time, the launch figure. And they don't have that yet. So they've just gotten rid of the countdown clock, and we are past, or rather we are into the launch window of Artemis 1. So from now until 3:04 in the morning, so a couple hours from now, that is this launch window for the rocket. And perhaps we can go and look up, I don't know off the top of my head, but we can go and look up the next launch window for it. Okay, so Space Launch System. That's all well and good. What are the other parts of this Artemis 1 mission do we have here? Well, we have the Orion spacecraft, and here's a nice animation of that. So we don't have the service module included in here, the upper stage rocket system in here. We do have the service module. And then we have the Orion capsule, and this is where the astronauts live. That's the habitable zone of the Orion spacecraft. And there's the service module. And it says we have power, propulsion, thermal control, air, and water coming from the service module. Just like the service module of the Apollo era. You have the solar wings that are providing electric power to the entire spacecraft. On top, you have the launch abort system. And that's going to help save the astronauts if anything goes wrong with the rocket itself during launch. Eventually, you don't need that anymore, but it's particularly for the first stage of the mission during launch from the Earth. So that's a critical safety point of this rocket, is that if they realize they have to abort the launch, but ignition's already well underway, they do have a backup system with the launch abort system that can save lives. So that is fantastic to see on board the Orion spacecraft. Because of course there is inherent risk to space exploration. Many have lost their lives in the effort to advance deeper into the cosmos. And it is, to some degree, the nature of this effort. It's an unfortunate aspect, and the more lives we can save throughout, of course, the better. So very critical to have a system baked in to the Orion spacecraft. Okay, so let's carry on to the next step. We have the Lunar Gateway.
Home. For me, home is where my family is. But there have been times in my life where I was called away from my family for extended periods of time. While I was serving in the Marine Corps, it was hard to be away from my loved ones. But thankfully, I had my squadron family, but other places where we were stationed around the globe became a temporary home. Then, in 2009, I launched the International Space Station, traveling even farther away from my family, conducting science 250 miles above the Earth. The space station was an orbiting home for my crewmates and myself. Talk about a room with a breathtaking view. With Artemis, NASA will send the first woman and the first person of color to the moon. We are going there for the benefit of all here. We'll need a place to orbit around the moon, where we can live and work, a place to get ready for our lunar surface expeditions, and a place to return to when our work on the lunar surface is complete. We need a lunar home away from home. This will be the Gateway. Starting with the power and habitation modules, the Gateway will be the first long-term outpost in lunar orbit humans have ever had. Primed for new discoveries, this orbiting laboratory will provide us with a unique view of our solar system. And it's already becoming a beacon for the future of international and commercial cooperation in space. With increasing capability and longer missions over time, the Gateway will be a powerhouse of technology and science, paving the way for future human missions to Mars. Design and fabrication of gateway elements by NASA and our international partners is well underway around the world right now. Wherever you are on planet Earth, today you are part of the Artemis generation. I'm NASA astronaut Randy Bresnik, and I invite you to join us by following NASA Gateway on social media and telling us where you call home.
All right. And yeah, what's brilliant about that, let's see if I can get a good image of Gateway here. That's not so bad right there. So mind you, the Gateway is not a replacement for the International Space Station, but it will enhance that for sure. And what's great about this is that this is a space station well beyond low Earth orbit. And in fact, it's in orbit around the moon, and in that very elliptical orbit. And it does, collectively with the Orion capsule, grant access to more, in fact, the entire surface of the moon, if need be. Now, again, their focus for the start of the Artemis missions is on the south pole of the moon, but they can look beyond that now also to beyond Artemis III with future missions at any point along the surface of our moon. So that's a very exciting aspect of Artemis and the Lunar Gateway as well. Now, it's also an internationally led mission. So it's not just NASA. We'll have definitely the ESA come into play here, the Canadian Space Agency, and it will be another great international effort, which does enhance our ability to work together here on Earth. And that just like the International Space Station is a beacon to that, and continues to be. During this very high tension conflict with Russia at the moment in Ukraine, we still have USA and Russian astronauts working together, and even beyond that, you have ESA and CSA and JAXA astronauts. They're working together on the space station. Now, it's just fantastic if you can find that sense of direction amongst multiple nations throughout the planet. So, another great international effort here with the Lunar Gateway. So, that's Lunar Gateway. We talked Space Launch System. We started to talk about the Orion spacecraft. I might have another slide about Orion coming up here. Actually, no, I guess we don't. So every astronaut is also going to need their own personal spacecraft. And now you might ask, what does that mean exactly? What's a personal spacecraft? Well, this would just be your spacesuit.
Moonwalkers, working in 1/6 Earth's gravity, will need spacesuits that let them use their hands and feet, walking to destinations and bending and reaching as they explore. For this new type of work, NASA has been testing prototype planetary suits, culminating in a new suit design, the XEMU.
The XEMU is Exploration, Extravehicular Activity, Mobility Unit. So it's an exploration spacesuit. So it's a spacesuit that you're going to use as we move forward on Gateway missions and on the lunar missions with Artemis. And then we're using all that to test the suits you would want to use to go to Mars in. So eventually you're going to have to be very independent and very confident in your hardware when you go and do a mission that far away from Earth. The new suits, the planetary walking suits we're working now, we really hope to provide improved mobility and comfort along with reduced injury potential. And really, like I said, provide the best tool to the crew member that we can provide. Then we want to be able to provide them the ability to kneel down and pick up a rock, like they're going to want to do in their geology science that they're working on. We want this to be a very reliable and durable suit so they can use it day after day in a dusty environment and not have to do a lot of maintenance with it while they're needing to do their mission. So there's a lot of those kinds of aspects that go into improving the suit that we're going to provide for the lunar missions.
All right, so that's the XEMU astronaut spacecraft, really spacesuit. But when you think about it, it is your own personal spacecraft. It has all the life support systems you need. Sometimes you even have ways to help you navigate space. You know, you get I can't remember the exact attachment, what it's called, but you basically snap a jetpack onto your spacesuit, and that really turns it into a spacecraft that allows you to have a fuel source and you can move yourself around. That's not too commonly used, but it does exist. And as we look forward to future missions both on the moon and Mars, we do need to consider how can we make our spacesuits better? How can we make it give you, more dexterity in your hands as you pick up objects? If you've watched the videos of the astronauts during the Apollo era, there are some really great compilations out there about how they had to move around on the surface in that low gravity environment in this big puffy spacesuit. They can be quite entertaining. Because they're the first ones to figure out, okay, how do I do this? How do I navigate in this weird environment with this cumbersome suit? And, they came up with bunny hopping around on the surface. When they fall, they have to do some interesting techniques to push themselves back up. So it is pretty cool that they're thinking about advancing the technology enough to allow for more comfortable spacewalks and moonwalks, for that matter. All right, so that's the spacesuit that they're going to use. Now, I did get a question in the chat from Deb asking what time is the potential launch for now, and they did get rid of the T-minus 10-minute waiting window, which was a waiting period as they worked out any potential issues with the hope of resuming that clock, and that did not happen. It looks like they've gotten rid of the countdown clock as they continue to resolve those problems. So at this stage, it doesn't seem like they've canceled. They're going to keep trying to push because they still have over an hour to try and launch this rocket within the launch window. But after 3 o'clock in the morning, if it hasn't launched by then, it will have scrubbed. So, and it's possible they might, if they realize these issues are too problematic, they might just push it even well before 3 o'clock. We'll see what happens. But we'll take a look later, see if we can find the next potential launch window. They might even announce it during the live stream here when we go back into viewing the NASA stream. Okay, what else do we have as we discuss the Artemis mission? Well, we have the Artemis III landing site, and there are still several candidates for where the specific landing site will be, but they are choosing the moon's south pole, as we discussed earlier. That's because there are potentially extensive sources of water at the South Pole. We know there is water, but they're still working out exactly how much. And we know that we can use water to make rocket fuel. No, we can't just we could use it, of course, as a resource for the astronauts. We need water to survive, right? But it's also, more importantly, can be used for rocket fuel. And if they're able to find a good, steady source of it there, the moon really becomes a way station for future missions to other areas of the moon, perhaps, or maybe looking beyond to help with missions to Mars. So the potential is almost endless here as we think about what water can do for us on the moon, and also if we find good resources on Mars as well, what it will do for us there. Now, there is a mission coming up soon here, a robotic mission that's going to help us figure out how much water is located at potential landing zones at the South Pole. And one we talked about earlier was the IceCube satellite that's part of Artemis I. it is launching with Artemis I. It's a small cube satellite that's going to look at the South Pole and study those resources from above. But it's always better to go at the surface level, to explore on the surface. If you can't do it with humans, try it with a rover. And that's, of course, what we've done with Mars for many years. And that's what they're going to do with this rover they're going to send called Viper. And I have a video covering Viper here that's going to explain what this rover is going to explore at the South Pole. So here's the Viper rover.
The future of human space exploration is being driven by what we can discover and accomplish on the moon. And with NASA's confirmation of ice existing at the lunar South Pole, the critical task of finding and mapping where water exists, what form it is in, and where it came from can now begin. Leading us on that journey will be NASA's first mobile robotic mission on the moon, known as Viper, the Volatiles Investigating Polar Exploration Rover. It will be delivered to the Nobile region of the South Pole as part of NASA's Commercial Lunar Payload Services Initiative. This region sits just outside the western rim of Nobile crater and covers an area of 36 square miles. As the first ever resource mapping mission on the surface of another celestial body, Viper will roam the surface equipped with 3 science instruments and a drill to detect and analyze various lunar soil environments at a range of depths and temperatures. The rover will venture into permanently shadowed craters, some of the coldest spots in the solar system, where ice reserves have been preserved for billions of years. NASA had 4 critical parameters when choosing a landing site for Viper: available sunlight, Earth visibility for communications from the moon to the Earth, data showing the potential presence of water and other resources, and terrain that is well suited for Viper to navigate. The area to the west of Nobile crater met these conditions. Once on the surface, Viper's mission will last 100 days and cover between 10 to 15 miles. And while a baseline traverse route through the Nobile region has been identified for the rover, the scientific discoveries Viper makes along the way will actually influence where the mission team sends it next, so its planned route will most likely change. During its travels, Viper will visit at least 6 locations where data suggests ice could be found. By helping determine the locations of where water and other resources exist, Viper's findings will help pave the way for future landing sites under NASA's Artemis program. The prospects of achieving a long-term human presence on our moon never looked so bright.
Okay, so they talked about here, we'll pause it right on that screen, that looked good, with the Artemis logo and the Earth. Very nice. So, that video talks about the purpose of the Viper rover and how it, well, not directly by name attached to Artemis, it is a critical science mission that's going to help us hunt down these resources of water on the moon. And it also mentions why we're finding it at all in the South Pole. And that's because there's areas there that don't really receive sunlight in those cratered regions at the South Pole. So that allows us to potentially go there, send this rover there, and study those darker zones. These are areas where the sunlight hasn't touched them in a very long time, potentially billions of years. And the water's just been preserved there because it's among the coldest areas, not just on the moon, but in the solar system. So that's what they're on the hunt for with the Viper rover. So there will be a rover going to the moon. In fact, I think during the lunar eclipse live stream that we ran on November 8th, there was a question about, are there any lunar rovers on the moon? And we talked about some of the Chinese rovers that are there. I think the name was Yuzu, if I recall. But there was a couple. And I think there's one currently operating there now, whereas NASA doesn't have any at the moment, whereas it does have several on Mars, of course. But Viper will be among the first NASA rovers to explore there at the South Pole. Okay, so that's Viper, the Viper rover. Okay, so let's think about beyond Artemis 3, okay? Where can we go beyond Artemis 3? Well, there's some really neat technology that's being developed. And in fact, Kopernik is working as a NASA partner at the moment to help bring STEM activity that's based on what NASA's doing with 3D printing. So we're very excited about that. And perhaps you can look forward to some future announcements on what we did with that program. We're going to some local schools nearby to test it out, amongst our other activities related to humans in space and Moon to Mars exploration. So that's going to be very neat. But yeah, going into how they're thinking about building these habitats for humans visiting both the moon and Mars. You can see this particular 3D printer that's depositing clay-like material. It's based on you don't bring the material, the 3D printing material with you. You actually collect material on Mars. You might mix it with some binding agents that you did take with you from Earth, and then you deposit it with a robotic 3D printer, just like we have 3D printers here on Earth. And you can see it's depositing layer by layer there to build up a structure. And the technology for this is actually pretty promising. We already do 3D print some habitats here on Earth. So taking that and applying it to the moon and Mars is going to be very valuable. So future Artemis missions may build permanent bases on Mars using 3D printing technology. And I have a video that demonstrates this from one of NASA's international partners with the European Space Agency. Oh, and Vinny here in the chat is asking, is this going to happen? Not sure as of right now. They are currently on hold for the moment as they work to repair a couple of different issues. I think the leaking is no longer a problem, but there is an issue with the Ethernet switch for the range system that helps communicate where the rocket is going, where it will be in the sky, and it passes that information off to different aircraft here on Earth. So that's the primary issue I think they're still working to fix at the moment. They halted the T- countdown, so they don't have a clear picture of when it will launch tonight, if it in fact does. If they can get that system repaired, then there is a chance that it could launch within the next hour or so. But they have until 3 o'clock in the morning, so about an hour and a half, to launch it within this window. Of course, there will be another window in the future. All right. So here's a little video from the ESA about possible lunar habitats on the moon.
Planet Earth is protected by the atmosphere, the layer of air and gas that surrounds it. The atmosphere shields the Earth from solar radiation, keeps the temperature balanced, and protects us from meteoroids. On the Moon's south pole, you can see almost perpetual sunlight on the horizon. This is the site of our lunar base. Conditions on the Moon are very different from those on Earth. Because the Moon has no atmosphere, there is no protection from solar radiation. There are extreme temperature fluctuations, and there is no protection from gamma radiation, and no protection from meteoroids. The lunar lander has detached from the rocket launch and is on a course to Shackleton's crater, the Moon's south pole. Inside the lander is a cylinder which contains an inflatable dome and 2 robot 3D printers. After the cylinder containing the habitation capsule has been unloaded, a dome is inflated from one end. This provides the support structure for construction, a little like scaffolding is used to build on Earth. The lunar habitation is built by a robot-operated 3D printer. At one end, it has a scoop to collect the regolith. In the centre are the containers for the printing material. At the other end, there is a robotic arm with a printing head. The robot collects regolith from the Moon's surface. Layers of this moon dust are built up over the dome to create the protective shell. This process takes about 3 Earth months. The shell is made up of a hollow, closed cellular structure. Under a microscope, it would look very similar to the close-up of a bird's bone. Like a bone, it is light and incredibly strong at the same time. When the lunar base is complete, it can house 4 people. Inside the dome, they are protected from meteorites, gamma radiation, and high temperature fluctuations. The original capsule functions as an airlock and technical support module. The skylights draw daylight into the living and workspaces, which are sheltered within a pressurized enclosure. This method is a pioneering advance in space-age construction. At Foster & Partners, we're used to designing for some of the world's most extreme climates. We often use materials found locally to create sustainable buildings on Earth. While the Moon is an exciting new territory for architecture, the value of this logic endures.
All right. So, yeah, definitely a very high concept, I suppose, example of this, of 3D printed habitats on the Moon. But the technology is there, and it makes a lot of sense to use material on these objects rather than take stuff with you to build something. So if you can use the regolith on the Moon or Mars and 3D print yourself a protective shield, then you can bring lighter weight materials that inflate, like they discussed here, and surround that with the surface of the Moon effectively. You're just 3D printing with lunar surface material. And that also will help you protect yourself from radiation, both cosmic and solar radiation. So there are a lot of advantages to building habitats using this method, and it's very exciting to think about where the future can go with that as they build more permanent, semi-permanent bases on the Moon, and maybe one day Mars as well. Now, while you might not have a ton of humans living on these objects all at once, because of course the best place to live is always going to be here on Earth, well, as long as we keep it healthy, right? Or try to keep it as healthy as possible. These are a good potential solution for solving multiple problems. You need a habitat, you need a strong structure, you need protection from solar radiation. So we'll look forward to seeing how this technology plays out. Okay, so that does wrap up my set of slides here. I was hoping, I'd break this up a bit, maybe halfway through we would tune into the NASA stream, but there just haven't been many developments so far from when we started this slideshow. I've been watching the stream above me here. That's what we have going in this window if you're just tuning in. And I think let's just jump in there and see what's going on. See if there's been any changes. Like I said, they got rid of the countdown clock. So let's just turn their audio on and see what's going on.
Constraints and weather is go for launch.
Oh.
Copy LWO and mission manager.
What's going on? That sounds maybe promising.
And mission manager, launch director.
Launch director, mission manager on 232. The mission management team has been pulled. You have a go to proceed with terminal count and launch of Artemis I.
Ooh. Okay, this sounds...
copy all, thank you.
This sounds promising.
And NTD, launch director.
Go ahead, launch director.
Yes, sir. On behalf of all the men and women across our great nation who have worked to bring this hardware together to make this day possible, and for the Artemis generation, this is for you. At this time, I give you a go to resume count and launch Artemis I.
Wow, all right.
Copy, launch director, and thank you. All right, we do have a couple of steps to configure, and then we will be ready to resume the clock. CVSE, NTD. CVSE here. Initiate recording of Orion cameras at this time. In work.
Wow, I promise I didn't time this. We're tuning in just right mowing.
Arm rotation enable.
NDT, RSR, booster ignition, SNA, arm, and rotation enable is complete.
And I copy, thank you.
Okay, so there you heard the poll from launch director.
Early.
Getting ready to get that new T0 time.
They sound pretty hopeful. Maybe not hopeful, confident.
The poll that you heard was the NASA test director's poll. And
all right, and we have verified no cutouts at this time. And all personnel, we are going to resume the clock. GLS, you can resume the clock on your mark.
Let's find out.
GLS copies. Countdown clock will resume on my mark. 3,
what do we have?
2, 1, mark. GLS mainline has been initiated.
Okay.
T-minus 10 minutes and counting.
We are T-minus 10 minutes away from liftoff of Artemis I. As you can see, the clock is now moving. Let's put that up.
We're getting right to it.
T-minus 9 minutes and 47 seconds.
Okay.
The L-minus 15 poll.
It's happening, guys.
6, 47, 44 is the new liftoff time.
Affirm.
Okay.
All right. They're confident. This is, I think, the first time we've seen 10 minutes and counting.
1:47 a.m. Eastern Time and 44 seconds.
Man, look at all those people. I'd love to be there. Oh, that'd just be incredible.
We went straight into terminal count.
Biggest rocket to launch since Saturn V.
Liftoff now 9 minutes away. So terminal count. Control has been given over to the GLS, the ground launch sequencer, a computer and software that is doing all of the commanding and monitoring of the Space Launch System. We'll hear call-outs from the GLS operator, Alex Pandalos. As well as NASA Test Director Jeff Spaulding. GLS is pre-tensioning the umbilicals at this very moment. You can see them as they run down the rocket. That's getting them ready to detach. At liftoff, those arms will swing away. We'll let go of the rocket in a clockwise direction.
So overall, it sounded like smaller issues today that they were able to work out pretty quickly, because we're only
T-minus
an hour and a
8 minutes
half after the start of the launch window. So
the GLS is
they were able to
performing
correct
up to 100 commands per second, including configuring ground systems for power transfer to the rocket. GLS is turning on cameras, recording video inside and outside the crew module to collect
Lots
data
of
for engineers.
cheering in the chat here. That's great to see.
Purging the aft skirt booster with high flow nitrogen. Clear out any hydrogen gas that may be there.
So they have to keep that hydrogen fuel tank topped off because it actually evaporates away.
You can see the crew access arm is already retracted.
As time goes by.
When there is crew during Artemis II, it would happen at T-minus 6 minutes. But out of abundance of caution, they went ahead and retracted the arm well ahead of liftoff. Want to point your attention to the base of the mobile launcher. If something wasn't done to reduce the power from the pressure caused by the rocket's ignition and thunderous sound, it could damage the rocket. So the ignition overpressure and sound suppression system will flood the mobile launcher with water. You'll see that sequence start at T-minus 17 seconds.
As usual, they're doing an excellent overview of the step-by-step.
The ground launch sequencer will start bringing the high energy systems online, starting with core stage pressurization.
Oh, almost 6 minutes.
Firing room 1 is completely silent as they listen for the next call.
GLS is go for core stage tank pressurization.
So again, that white cap
The core
top
stage
is the
tank
Orion
is now
spacecraft.
pressurizing to flight levels. The replenish valve to the liquid hydrogen tank now closing. The liquid oxygen tank will come a little later. Now we're arming the Orion ascent pyros and transfer to internal power. The launch abort system, or LAS jettison motor, is now armed. On this flight, the abort motor is inactive because there is no crew on board. Up next is the flight termination system, or FTS, which gives the Space Force the ability to destruct the rocket if it goes in the wrong direction. Let's listen in for that.
So they were talking about how they deactivated the Orion
The flight
launch abort
termination
system
is now armed.
because there's no crew,
Coming
so
up
no
at
reason to have
4
it
minutes,
active.
at 40
They've
seconds,
already
a big
tested
moment.
it
This is
before,
where the
so they know it
RS-25
works.
engines and their bleed go to high flow. It's been a little tricky to dial in.
GLS is go for LH2 high flow bleed check.
Good word, we've passed that. The cryo team got the LH2 engine bleed pressure loop dialed in. They are now at the right temperature for launch. Countdown continues. T-minus
Positive
4
progress.
minutes, 15 seconds. Up next, GLS fires up the KPUs. Those are high-speed
That's what you love
turbines
to
which
see.
provide pressure to hydraulic pumps that steer the RS-25s. Stands for Core Stage
this is
Auxiliary
definitely
Power
worth
Unit
staying
Start.
up for.
GLS is go for core stage APU start.
That now leads to the thrust vector control test at T-minus 2 minutes and 30 seconds. That can proceed now, and we will see the engines gimbal at the bottom of the core stage.
This is really a historic moment, everyone.
At T-minus 3 minutes and 10 seconds, you will hear the go for
I'm sure you know
sequence
that, but
4. That's a helium
I had to say
purge
it.
of the 4 core stage engines downstream of the propellant valve, getting the air and moisture out.
GLS is go for purge sequence 4.
And in just a few seconds, GLS will close the core stage LOX vent, liquid oxygen.
3 minutes. 3
The
minutes.
white vapor cloud caused from the super cold gaseous
They're going.
oxygen
They're
condensing
trying.
the water
At this
in
point,
the
you know,
atmosphere will disappear. You see it coming out there now.
there's very little it sounds like that would stop them from a
And
launch
there it
attempt
goes.
here.
It's closed. LOX vent closed. Pressure rising in the core stage LOX tank to flight levels. Coming up in 15 seconds, look for that thrust vector control actuator test. Engines will gimbal. And there they go. The 4 core stage RS-25 engines gimbaling around, testing the ability to steer the rocket into space.
Check that
They will
box.
operate at 109% performance. Each RS-25 throwing down 500,000 pounds of thrust. All 4, 2 million pounds. All together with the boosters, 8.8 million pounds of thrust.
GLS is go for upper stage to internal power.
Now the upper stage has gone to internal power. So power is removed from the rocket's
It's
upper
too bad
stage,
that this is
the
happening
ICPS, and it's been switched to
early in the
battery
morning.
power. The same milestone is coming up.
The
for
first
the core
attempt
stage
was
at
very
T-minus
good
1
timing.
minute and 30
Prime
seconds.
time. But people will wake up to a historic moment in the morning today. And you're here spending time with us to watch it live. So thank you for tuning in,
GLS is go for core
both
stage to
NASA
internal
stream
power.
and our live stream.
The rocket's core stage, which houses the 3 flight computers, is now on battery power. So there is no more hold time available because there's no more margin on the batteries. So if we have a hold, we'd have to recycle back to T-minus 10 minutes and recharge those batteries. The count continues. A note now, shortly after liftoff.
1 minute.
Shortly after liftoff, Mission Control Houston will take control of the rocket, and my colleague, Leah Cheshire, will take over commentary. T-minus 50 seconds and counting.
Here we go.
Coming up at T-minus 33 seconds, the GLS will hand off control to the ALS. This is the autonomous launch sequencer. On board the rocket, it will take over command and control of the rocket. But the ALS will check, make sure there's no holds coming from the ground up until T-minus 2
GLS
seconds.
is go for ALS.
And we are go for ALS. The Space Launch System is now counting down to liftoff of Orion on its maiden voyage to the moon. Launch team can no longer recycle the count. Sound suppressor water now flowing
We're
under
going.
the ML.
We're going.
And here we go.
10.
Hydrogen burn-off igniters initiate. 7, 6, 5.
Is that flood
Core
water
stage
coming
engine
in?
start. 3, 2, 1. Boosters in ignition. And
Wow,
liftoff
look
of
at it
Artemis
go.
I. We rise together back to the moon and beyond.
Keep
All
going,
4
Artemis.
RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis I. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket.
So far, so good.
SLS now traveling 607 miles per hour.
Nah, no big deal. It's not that fast.
You're looking at 8.8 million pounds of maximum
Totally
thrust.
just-
Quiet here in the loops in Mission Control. 4 core stage engines are throttling down ahead of passing through max Q.
Imagine what that sounds like if you're there.
Now 1 minute, 21 seconds into the flight, traveling at 1,420 miles per hour. 4 core stage engines are back at maximum thrust. The next major milestone will be for the solid rocket boosters to cut off and jettison at about 2 minutes and 11 seconds into the flight, so about 30 seconds from now. Again, quiet here in Mission Control Houston as teams continue monitoring the flight of Artemis I. We're now 16 miles downrange from the launch pad at Kennedy Space Center, traveling over 2,800 miles per hour. Standing by for solid rocket booster jettison and shortly thereafter.
Are they popping off? Oh, yep. There they go.
Confirmation that the solid rocket boosters have separated, these 177-foot boosters.
Yep.
Now the core stage continues to power the flight of Orion, all 4 RS-25 engines firing, traveling over 3,400 miles per hour, 46 miles downrange. 2 minutes and 36 seconds into the flight. Hearing nominal calls here in Mission Control Houston. We've still got 4 good engines on the core stage. Next up, we'll be looking for the service module fairing to separate. This is 3 15 by 15 foot fairing panels, providing structural support, protecting the service module. Those will separate at about 3 minutes and 11 seconds into flight, and very shortly thereafter will be followed by the launch abort system separation.
Okay, yeah. I wasn't exactly sure what stage.
Just over 3 minutes into the flight of Artemis I, now traveling over 4,060 miles per hour, 83 miles downrange. We just had confirmation that the service module fairing has separated. And that the launch abort system pyros have fired, separating those from Orion as well. For future crew members.
No. There's audio on from them. I don't hear them. They were saying something and now they're not.
We just heard the call for 3 engine press, meaning if SLS were to lose an engine at this point in the mission, we could still achieve a nominal mission. We would just have an extended main engine cutoff time. However, we still have 4 good engines, all at maximum thrust right now, powering the first flight of Artemis at 5,200 miles per hour, 148 miles downrange.
That's cool they have that redundancy baked in, that they can operate on 3. Just longer burn time. They have the fuel, you just burn longer.
We're 4 minutes and 16 seconds into the flight of Artemis I. So far, we've had a clean ascent. We saw those solid rocket boosters jettison about 2 minutes and 11 seconds after liftoff. Shortly after, we had the service module panels fairings separate, as well as the launch abort system. The launch abort system was inert for this flight, except to perform this separation. Those 4 core stage engines will continue to fire and power the flight of Artemis I, now traveling over 6,800 miles per hour, 229 miles downrange. Booster flight controller reports that the engines are looking good.
All right. Yeah, it's in the daytime we would have had more of a visual on this to some degree, although this stage is just getting too far away.
Time is about
anyways.
8 minutes and 3 seconds. We are now at 5 minutes and 11 seconds into the flight, 7,656 miles per hour. Again, 4 good core stage engines, those 4 RS-25 engines. The last time those core stage engines flew, they were taking space shuttles to orbit, and now with upgraded capabilities, they're launching the future of human spaceflight.
That's incredible. See, so that technology get recycled into this rocket.
5 minutes, 42 seconds.
I know there are
into
critiques
the mission.
of
We are now
that,
traveling 8,800 miles per hour, 345 miles downrange from the launch pad at Kennedy Space Center.
It's definitely interesting to see the legacy play out here of the space shuttle program now to Artemis.
We are anticipating core stage main engine cutoff at about 8 minutes and 3 seconds. And about 10 seconds later, we'll see core stage separation, at which point Orion and the interim cryogenic propulsion stage will be flying free. Now traveling over 10,000 miles per hour, 6 minutes and 15 seconds into the flight of Artemis I, 427 miles downrange. Quiet here on the loops in Mission Control Houston. Teams continue to monitor this first flight.
So I imagine still a 3-day trek out to the moon, but Orion's going to be in orbit around the moon for over a month.
About a minute and a half now until
And then it'll
core stage
return
main engine cutoff time.
and land
Our
in the
full
ocean.
core stage engines continue to fire at maximum thrust.
I mean, for the most part, we're past, the riskiest part of the, space launch system itself. The rocket seems to be working really well.
Coming up on 7 minutes since launch today, now traveling over 12,800 miles per hour, 563 miles downrange. Again, still quiet here in Mission Control, Houston.
And this is why we waited, right? Why it was delayed.
As we prepare for main engine cutoff,
they delayed it for the hydrogen leaks. Today they even delayed it for a small leak and then the range issues with the Ethernet switch. But now we have it in orbit around the Earth, or nearly, and
30 seconds now until core stage main engine cutoff. All 4 engines continue to throttle down.
All right, so the burn is almost done on the core stage. So it's almost, imagine it's time to separate. Oh, SLS separation is coming up. Yep, I see it on their timeline.
Continuing to hear good calls here in Mission Control, Houston. We're standing by for core stage main engine cutoff.
Oh yeah, main engine cutoff is coming up. I see. That's the next step.
And we have confirmation of core stage main engine cutoff. Orion is now in Earth's orbit. The flight dynamics officer reports that we have a nominal main engine cutoff. And we just heard the call for core stage separation.
There it goes.
That means Orion and the interim cryogenic propulsion stage are now flying free from the core stage of the Space Launch System.
Another huge step.
The next milestone will be solar array deploy approximately 18 minutes after liftoff. But before Orion stretches its wings, let's check back in with our friends at Kennedy Space Center and hear all about what it was like to hear the rocket roar off the launch pad.
Oh yeah,
Megan and Kayla,
gotta stick around for this.
Well, if you're just joining us, welcome to NASA's Kennedy Space Center, where we just watched Artemis I launch, our first step towards our next adventure into deep space. As Leah said, I'm
this is just contagious, isn't it?
NASA astronaut Kayla Barron, and I'm kind of still giddy and speechless. I don't even know how to explain how I'm feeling right now.
I feel the same way. This is the first launch that I've been able to watch in person. And I've got to say, it was incredible. It took my breath away and I was tearing up. Just what an amazing accomplishment for this team, this international team, people who have been dedicating their careers to getting this rocket off the ground and taking the first step to getting a crew on that vehicle back to the moon. It was just incredible.
Yeah, this is a moment I think that we're all going to remember where we were when we saw this sort of thing, you know what I mean? And it was great to see, again, when we entered into terminal count, everybody here just started cheering, coming out to get a really good view. And boy, I mean, it lit up the night sky and it just shook everything around us. Did you feel that? Like in my bones, I felt that.
Oh yeah, the cool thing is just kind of the delay between.
Let's turn the volume up on this.
Here, because of course the sound travels a little bit slower, and it was just amazing. The ground shook. We could hear the thrust pushing that rocket into space. 8.8 million pounds of thrust.
Yes,
it's incredible. It was amazing to see here live in person.
How does it compare? So this is your first launch on the ground. How does it compare to your launch when you're in the capsule soaring towards space?
I mean, equally emotional, I think. Yeah. We train for everything, and so when we're in that capsule waiting for launch, we're just running our procedures. You could almost, trick us and say that we were in the simulator and it wasn't real, but like in that moment of liftoff, when the thrust builds underneath you, like we saw it today, it's just hard not to be overwhelmed by the emotional experience, the excitement, the joy of that moment. It's incredible.
Yeah, I think we can't say it enough. This team really deserved this moment. They've been working so hard for this moment. When I heard that we got into terminal count, it was, I felt a sense of relief and excitement for them that I think everybody here did. We really wanted them to succeed. We really wanted to see the launch today. And wow, I will never forget this.
Me neither. It was an incredible experience to be here and see that happen.
Yeah. Was there anything that was particularly surprising to you? Again, this is your first launch. What were you expecting?
You know, I think we also had a nighttime launch for our launch, and so I think one thing you underestimate is how much it lights up the night sky.
Yes.
We were able to watch it all the way through that trajectory. We were able to see the boosters separate and everything. So it was just an incredible view. It's amazing how much you get to see of the flight path when it's at night and it's lighting up the sky.
Yeah, and I don't know if you noticed this, but we see the moon here, and the trajectory of the rocket looked like it was flying towards me. You know
That's so cool. I was wondering if that's
so
what they were
poetic.
trying to show.
It's so beautiful.
In that one clip, it looked like they were catching the main booster.
We're gonna head over to Daryl, who
and the moon in the same shot. And yeah, it did. If that's what it was. It did look like it was on its way to the moon. Not necessarily the case. It's going in orbit around the Earth first. But yeah, like they said, poetry in action there, just to see that play out in the night sky.
Blackwell Thompson is about to address her team after a whole lot of hard work and preparation to get to this moment. Let's stand by and listen to her now.
All right, what's going on here? Let's turn up the volume.
Comm check. But you can't hear.
Well, for mission control.
Can you guys hear me? No.
Don't worry, NASA. I know this feeling very well. When some tech doesn't go as planned.
The room can't. You can hear me? Because the guys. I don't know what he's telling me to do.
All right. Well, while they figure out, it sounds like they're gonna, excuse me, make a speech at Mission Control. And I see some good comments in the chat here that came through. So thanks for tuning in, everyone. Yeah, it doesn't look like they have cameras attached to the spacecraft, although that might not be. I imagine once Orion goes in orbit, I have to think that they, either with the CubeSats or with the Orion spacecraft itself, they have some way to retrieve imagery from the surface. CubeSat will definitely be doing that. In fact, the IceCube, the IceCube CubeSat. Well, yeah, thank you for tuning into the stream.
Oh, there we go.
It's a very kind comment there. Oh, wait, I think we got audio.
Well, for once, I might be speechless.
I can only imagine. That's just.
So you guys know I
what
have
an
talked a
accomplishment.
lot about appreciating the moment that you're in. And we have worked hard as a team. You guys have worked hard as a team for this moment. This is your moment. It is not by chance that you are here today. So I want you to look around at this team and know that you have earned it. You have earned your place in the room. You have earned this moment. You have earned your place in history. You were part of a first. Doesn't come along very often. Once in a career, maybe. But we are all part of something incredibly special, the first launch of Artemis. The first step in returning our country to the moon and on to Mars. What you have done today will inspire generations to come. So thank you. Thank you for your resilience. You know, I said at the pre-test briefing, the harder the climb, the better the view. We showed the Space Coast tonight. What a beautiful view it is. So congratulations. So we got a couple of traditions here in launch control. And the first one is when you're in the position for the first time, you get a tie cutting. And so I have my launch director scissors. And I'm going to get my tie cut by a couple of legends that are here. And then anyone who wants their tie cut will be making the rounds in the firing room. You got your console chiefs. If they want to do it, that's fine. If you want me to do it, you might have to wait a little while, but I'll stay all night if I have to. It'll be my pleasure to cut ties. So I'm going to take care of mine, and then I have one other presentation that I want to make this evening.
I was not aware of this, but this is interesting. It sounds like it's a time-honored tradition, though. All right, well, while we go through the tie cutting ceremony here, looks like they're just doing this on camera so we can lower the volume. In return, she said she has one more presentation potentially coming up. So, yep, there's the tie cutting.
This is Charlie Blackwell Thompson, Artemis I launch director. She just got her tie cut. That is a tradition here at NASA. We just got to hear her talk to the team, and one thing that really stuck out to me that she said is that they've really earned their place in history. We're coming up on solar array deploy. Let's go on to Leah.
Thanks, Megan. And yes, we're here in Mission Control Houston, still monitoring the Artemis I mission and the first flight of Orion atop the Space Launch System. So far, we saw successful liftoff at 1:47 a.m. Eastern Time, all the way through separation from the core stage. We now have Orion and the interim cryogenic propulsion stage flying free. And we've just heard that we have initiated solar array deploy. So we are turning our focus to that. The spacecraft was running on battery power, but stretching these wings will allow it to stop relying on those batteries and significantly extend the time it can stay in space. So solar array deploy takes about 12 minutes. We have 4 solar arrays that we need to deploy and latch. These will provide power to the spacecraft on its journey to distant retrograde orbit and all the way back to Earth. Once these are properly configured, again, Orion will no longer need to rely solely on battery power. And we expect this to be done about 30 minutes after liftoff. Right now, we're 19 minutes since liftoff
10
today.
minutes out then.
Orion is now traveling 17,175 miles per hour. We're continuing to hear good calls here in Mission Control Houston from the flight controllers monitoring the mission.
Okay, let's bring their volume down here. I'll bring it back up. So I wanted to answer one of the questions here from Lornaz. They ask, when is TLI, or translunar injection? And from what I remember from the previous launches, it should be about 90 minutes from launch. And you can see it's in the timeline here. So the TLI burn is on the timeline at the end, and then there's TLI cutoff, and again, that's translunar injection. So we should see that in about 90 minutes. Now, unfortunately, I do not intend to keep the stream going for that long. But you are, of course, once we end this stream, definitely jump on NASA's stream if you want to stick around and watch. The only reason I have to cut this stream early tonight is because I do have a planetarium program in the morning at a school nearby. So I got to make sure I'm rested up so I can deliver good presentations for them, of course. Yeah, that's coming up, the translunar injection. And again, yeah, this is on its way to the moon, and it will be on its 3-day journey as soon as that TLI burn happens. Oh, here we go. This looks like a real image. Maybe they're working on getting those cameras online. That looked like a real downlink from the spacecraft. Oh yeah, look at that. Yep, they're getting the camera feeds going.
Liftoff. Orion is attached to the interim cryogenic propulsion stage.
We saw the solar panels being deployed.
unfolding now. And again, Artemis 1 is a flight test. It's paving the way for a sustainable presence at the moon. Looking forward to the future, Gateway will be our space station in lunar orbit. And we have some similarities and differences in the solar arrays unfolding right now on Orion and those that'll be on Gateway. So like we're seeing now, these are deploying autonomously. The Gateway solar arrays will as well. And while these generate those 11 kilowatts of power, the two rollout solar arrays, or ROSAs, on Gateway will generate 60 kilowatts of power. That ROSA design is currently being tested aboard the space station. We have 2 new ones installed and a spacewalk conducted earlier today, preparing for another set. Coming up on 22 minutes since liftoff today, Orion and the interim cryogenic propulsion stage traveling over 16,800 miles per hour. The solar arrays deploying now are part of the European Service Module. It's comprised of 20,000 parts and components. The Service Module was developed as part of an agreement between NASA and the European Space Agency, or ESA. This is the first time NASA is using a European-built system as a critical element to power an American spacecraft.
And there goes that international connection there between NASA and the ESA, and why we'll continue to see that. Remember that 3D printing video we watched earlier was an ESA program. So we'll continue to see that level of collaboration with the Artemis program. And we saw the solar panels starting to unfold. Now, I do wonder if they will stabilize this footage, or if this is purely just coming from engineering monitors as they look at the different cameras on the spacecraft as they deploy the panels and they monitor that equipment. Maybe that's why we're just getting the flashes and we're not getting a direct downlink from the cameras. Now, I did notice someone earlier, where was that comment? Oh, it was Lornaz mentioning about SpaceX and how they have cameras all throughout the craft that aren't just for monitoring the course of the mission for mission control. It's also for really a marketability standpoint, and showing the success of the mission play out for people who are just watching it happen. And NASA's getting a lot better at promoting that aspect. But I hope it does continue to improve as time goes on. Because I think it is important to really go eyes on as best you can. I mean, I think back, the best example I think of NASA doing this was for the Perseverance rover landing in February of 2021. And they actually sent back a video of it descending to the surface, whereas with Curiosity, they didn't have that at all. They had some pictures, basically a slideshow at best, of the rover landing to the surface. But with Perseverance, it was a video. And the more that they can do that, the better outreach will be, and potentially the more generations you'll inspire, maybe the more funding you'll get too. Again, it's all about that marketability aspect of space exploration that does play a role in public perception. And also, it's just really cool. So cool to see that perspective on it. Because you can show people, it's not, you don't just have to go to the movies to see sci-fi and space exploration where it's all CGI. You can see this happen, see this play out. People are doing this. Engineers, technicians, astronauts, mission control, all the jobs that go into building this spacecraft and the process engineering that goes into it. From across the world, it's not like we saw, it's not just NASA, it's the ESA. It's various international companies around the world that are involved, and throughout the States, of course, as well. Our local Lockheed Martin helped build the glass cockpit system for the Orion space capsule. And you have companies from across the states that participate in different parts of that capsule, the rocket system, and so forth. So it really is just a collective effort of human ingenuity, and to see it be such a great success is just incredible. It took time to get here, and it certainly was not without its failures along the way. And of course, they never launched a failed rocket. They saw the problems with it, and they realized they had to postpone those launches. And they collected so much data from this. It's all going to be invaluable for Artemis 2 and 3. So just a phenomenal night, and I think altogether well worth staying up for. Alexis, that is a great question, and I did not think to look up the flight paths, if only because our conditions out here are not very nice in New York, and I'm not even certain that we could have seen it up this far north. But do a quick Google search is my recommendation. See if there's, well, actually at this point, you're going to be hard pressed to spot it. At best you'll see it as a satellite in the sky. And again, I'm not exactly certain of its flight path, and it's about to make its TLI, its translunar injection to the moon, in about an hour or so. At about the 90-minute point, it'll do its translunar injection, and that will take it on its course to the moon. So as we get closer to that 90-minute period, if you can see the moon, you might be able to see Artemis. So there's a chance for that. As it gets closer to the moon, of course, it's going to become less visible. It'll get dimmer and dimmer. But I imagine at the start of it here, at the start of TLI, you might be able to catch maybe some sunlight glinting off of it, if there's sun in its path. Alexis also asks, what does a TLI mean exactly? So the TLI is the burn that they're going to do. You're burning fuel. You're using the engines. As right now it's in orbit around the Earth. When it uses the TLI burn, that's going to put it on a flight towards the moon. You're basically reaching escape velocity from that point, at least, in Earth's orbit, because of course the moon's in orbit too. But you're going fast enough to get further out in orbit and put it on a path to catch up to the moon. And they'll have to do some burns, maybe some corrective burns, to put it in the orbit they want around the moon as they get closer. But it should be about a 3-day journey once they do that TLI burn. So that's coming up soon, in the next hour or so. So yeah, great questions, everyone. Like I said, I'm not intending to stick around until that TLI burn as much as I'd like to. I do have to get some sleep tonight because we have a planetarium program, but in the morning, and I got to make sure I'm awake for that because I got to do the shows. But I'm very excited to talk with the students tomorrow about this. It's entirely possible this will be the first people they hear this from, because it's happening so early in the morning. They'll be heading to school, and the first thing they hear from either their teacher or Kopernik is, "Oh, Artemis launched. It's successful. It's on its way to the moon right now after the TLI burn." And it's just going to be really exciting to talk about with the students, because that's the generation we want to inspire. They're the Artemis generation. And they're going to grow up in a world where astronauts have returned to the moon. And maybe we'll will lead us on a path to Mars. And in fact, maybe they'll be one of the astronauts to go to Mars. These are the students we want to inspire, and I'm just thrilled to talk about it with them. And so thankful for all the efforts of NASA, of the ESA, the engineers, mission control, everyone that played a role in this mission. I just am astounded at its success. Just, all of the delays, this has all made it worth it. The fact that we watched it launch tonight and it was a near flawless launch. They mentioned at one point they didn't lose an engine of one of the the 4 engines. They didn't lose one. They could have and still been a success, but all engines performed nominally. Just a terrific night. Even if we're all a little bit tired, perhaps it's just well worth sticking around for. So I'm so glad you all got to watch it live. Alexis mentioning that, they're very excited to see what images come back down from Orion. Yeah, I hope they do capture some really nice lunar images. I mean, because when you think about it, this is a human spacecraft designed to fly to the moon. We've sent orbiters around the moon more recently, like the Lunar Reconnaissance Orbiter, and it's mapped out very high resolution features. But there's nothing like considering this new perspective we're going to get on the moon when humans finally board this Orion space capsule. So yeah, I'm thrilled about what might come back too. There are some science missions on board Artemis I, including the Ice Cube satellite. I know that's a little confusing, but it's called Ice Cube because it's a cube satellite. It's a small satellite that's going to look for water at the South Pole, look for the water resources there. So really thrilled about what's going to come back from that. And we just have a great future to look forward to with the success of Artemis I. We talked all about earlier in the stream about where Artemis II is going to go, with a crewed mission that's just going to go in orbit around the moon. That might very well be on track now for 2024. I can't confirm that. I don't have any information about it. But because they launched this year in 2022, they may well be on track to launch Artemis II in 2024 as was previously scheduled. And then Artemis III may well launch in 2025 or 2026. And that will be an astronaut's land on the moon for the first time since 1972. So we've got a lot to look forward to with this. All right, let's tune into the NASA stream one more time. Again, I am starting to wind down the stream at this point, but we'll tune in the NASA stream. If you have any further questions, please post them in the chat. I'd love to hear any final questions from you or comments. And I'll wrap up the stream by answering any of those that come through after we watch NASA's stream for a bit.
It's, like I said, it's surreal and just amazing. I don't know about you guys, but...
They're nodding along behind you, for sure. Anything you want to say to the launch team? Again, this is a big day for the launch team, for you guys, NASA, but really the whole world. I mean, this is a historic launch that I think we'll all remember. Really.
You know, we had a lot of people here.
It's only going to get better.
A lot of teams, firing room. I'm sure that was hectic. And, NASA, Boeing, all the other companies did a great job. And we're glad to be part of it.
One thing I always like to say is spaceflight is a team sport, and I think you guys perfectly demonstrated that today, right? Like, none of us could accomplish this on our own. It takes a really complex team. Nobody can be an expert in all of the systems, all the technology, all of the workarounds we might have to do to get a rocket off the pad. So thank you for the role you played in that team today. It's awesome.
Thank you.
Yeah, thank you so much, guys. I appreciate you coming by to talk with us. All right, it's now been about 35 minutes since liftoff of Artemis I. Orion and ICPS are now free flying, so let's head back to Leah again to talk about how the journey is going so far.
Thanks, Megan. And it has been a pretty smooth ride so far. And we are now, again, like you mentioned, coming up on 36 minutes since launch. That puts us about 17 minutes into the perigee until the perigee raise maneuver. That's going to be the maneuver that lifts the lowest point of Orion's orbit around the Earth and puts us where we need to be ahead of the translunar injection burn. The translunar injection burn is that really long burn that we're going to need to send us on to the moon. So we've been treated to some exciting views from the spacecraft today, including, and we hope to see some from inside the cabin, but we expect to continue receiving photo updates throughout the mission. It takes a team, though, to bring the imagery of Orion down to Earth, so let's meet them.
Maybe this is where we'll wrap up.
And the mission itself is preparing to carry humans to the moon. The Orion Imager team is going to be monitoring every aspect of visual spacecraft performance for the entire duration of the mission. The first time that we're going to be live streaming digital video from its spacecraft back down to the Earth from the vicinity of the moon. That's never been done before. What we'll be transmitting live streaming will be lower resolution, more compressed, because we have to fit it into a thinner pipe, if you will. Every one of these cameras is in its position where it is and it's configured the way it is for a very specific reason. We're going to be monitoring anything that we can see with the cameras for spacecraft performance. The imagery teams at NASA are composed of dozens and dozens of very highly trained, very specialized people, engineers, technicians, analysts. If we can see it, we're going to try and keep an eye on it. Imagery has been invaluable throughout the history of NASA. We flew cameras on Mercury, Gemini, Apollo, all of that stuff that we saw with the astronauts around the moon. It helps us detect the unknown unknowns. It allows us to see things that we didn't anticipate happening before. So when we do fly people on Artemis II, we can have a high confidence that everything is working the way it should.
So that's actually invaluable information as well. And it's what we were discussing before, is that we will see video come back from this. And they mentioned it's low bit rate, it's lower quality because they need good data. They don't need clarity necessarily, but they need to get eyes on, and they need to get that consistently so that they can effectively live stream it back to NASA. Because as you drift further away from the Earth, the latency increases. And your ability to send those packets of info decreases. So this is also a good test of the communication systems so that when they do have astronauts on board, they can effectively monitor. Now, what, are they talking about CubeSat here? What are they? Let's see.
Yeah, it just really means that it's not a primary objective of the mission. We're not relying on the success of these CubeSats for overall mission success. It's kind of a bonus payload, right? A chance to deploy these satellites that have different sensors on them and collect some awesome data to support other research objectives.
Yeah, and I know battery life was a concern for some of them, but all 10 were deployed, and scientists, I'm sure, are eager to see what kind of information that hopefully they'll be able to get. And they're just some of several research projects on this flight that will help gather data about the moon and more.
Artemis I is paving the way for us to explore deeper and deeper into space.
I think Artemis I is significant on so many levels. It is a new frontier to do science.
So the primary objective is to test the Orion spacecraft integrated with the Space Launch System.
And it is designed to carry out the boldest of the bold missions.
But it's more than just learning how to travel in space. We're taking a lot of cool science along with us on this first mission to the moon.
So as NASA plans to go back to the surface of the moon and then onto Mars,
we want to spend more time there, and that's riskier business. So the more we learn about the moon itself and the environment where we'll be operating, the better we can prepare. We have 10 CubeSats we call secondary payloads, which are small scientific spacecraft of their own that will each be conducting their own scientific mission.
All of these payloads in some form or fashion will help us going forward. They are going to be studying the moon.
And they're going to help us understand what is the moon made out of, what types of rocks, what types of regolith, what types of ice, what's mixed in with water that might be present.
One of them actually is going to attempt to land on the moon. They're going to be studying the sun.
Understanding and studying the space
I didn't know about that one. I'll have to look that one up.
some different propulsion systems. These novel ideas will ultimately turn into the technology and the systems that we want to use.
Is there really a solar sail
There's
spacecraft
a
on
lot
this
of cool things going on between all these CubeSats that make up our secondary payloads. Additionally, inside the Orion, we'll be flying an experiment to study space biology.
Space biology is where we study the underlying changes that Earth-based biological systems undergo when they're in space.
Or basically, how does life respond to the space environment?
The level of ionizing radiation that you experience when you go beyond the Van Allen belt, so you go beyond the protective magnetic sphere that we have around us, you then get exposed to higher levels of ionizing radiation. So we are flying several space biology experiments.
We will take a series of materials,
plant seeds, fungi, the yeast cell, algae,
and ride along the trip. And then when it comes home, we can analyze how they responded to that environment.
So there are passengers on board, just not your human passengers. Fungi and bacteria.
We'll be learning about how to make astronauts more effective in the Orion in the future. An example of that is something called the Callisto Technology Demonstration.
Lockheed Martin built the Orion spacecraft for NASA, and we'll be flying a secondary payload that's a demonstration payload called Callisto. So we took the technology from Amazon for Alexa and the WebEx technology from Cisco, and so we built a digital assistant, if you will, a custom space-qualified Alexa.
Alexa, how does the life support system work?
Orion's life support system is the Environmental Control and Life Support System, or ECLS.
And so this payload is a demonstration mission to show how astronauts in the future could use this technology as an innovative user interface.
So there
wow,
you have it.
that's pretty cool.
I hope you agree with
There's
me.
another one I
This
didn't
is
know about.
Exciting.
I am just over the moon excited for the Artemis I launch.
The science we'll conduct on Artemis I lays the groundwork to ensure that we can safely conduct scientific activities at the moon with our astronauts going forward. This really is the stepping stone for us as we take that next giant leap in space exploration.
Okay, I'm really glad we stuck around for that one because there were some, it's a video I hadn't seen. I knew about some of the cube satellites, like the ice cube we talked about earlier, but I didn't know they were deploying a solar sail cube satellite. That's going to be pretty neat. And hopefully we do get some visual data from some of those. They even said they're landing one on the surface to study the moon. And this is the power of cube satellites. You saw they were holding one at the table, a model of one. They're pretty small, but our technology has come so far and we've miniaturized our tech and our instrumentation that you can fit a lot in those little satellites and do a lot of science with them. So that's fantastic news. They mentioned in the Orion space capsule, you do have passengers on board, and I saw a comment here that says they're first-class passengers. Yes, they are. They got plenty of space in their Orion capsule. And they're going to study how radiation affects those smaller life forms. What was I forgot. There was one more that excited me, and I forgot it. There was the biology experiment. Oh, the voice assistant. That was pretty interesting too. I mean, that's pretty sci-fi. It's going to be pretty cool to see play out in the future. Just to operate your spacecraft and check its diagnostics with, your AI, a little bit like HAL 9000. But I think that'll be pretty cool to see. Our smart assistants really aren't artificial intelligence, anyways. They're pretty basic in how they operate, but it's still really cool. Potential behind that system that they're testing out there. I did see another comment from Alexis that says, if anyone else is looking for planets and constellations, there's an app called SkyMap on iOS that they love to use. That's a great suggestion. Yeah, if you're looking for objects in the night sky, hunt down SkyMap, or there's a few other applications on both Android and iOS that will map out the sky for you and are well worth trying out so that you can figure out what's out there. There's lots to see this time of year, especially at least where we're located. You know, we have the planets out, we have some good constellations, we have star clusters like the Pleiades open star cluster, Orion, the constellations coming our way, the Orion Nebula with it. So lots to see in the winter skies as we head into winter. All right, I'm going to do a final call, one last call on any questions or comments. If you want to submit something in the chat, I can read and respond to those. But yeah, I want to say again, I'm so glad we got to see it launch tonight. It was well worth sticking around and staying up late for. And I want to thank you all for joining me this evening. Definitely, reach into the NASA stream if you want to keep going. That TLI burn will be at about the 90-minute mark, T plus 90 minutes. So it's coming up. And that will be when it starts on its way to the moon. Still in orbit around the Earth right now, but at that 90-minute mark, it's going to head off to the moon for its 3-day journey. We'll be back for future live streams. You can look forward to this week's Friday Night Live, our FNL program, that is going to be on the big snowstorm that happened in our area in 2020. That'll be a nice presentation. And then we also have the following week, Black Holes on Black Friday, which is always a fun one. And finally, in early December, we're going to have a couple of Night Sky Live programs. We haven't posted them yet, but look out for them. The first one is on December 7th, and that's going to cover the lunar occultation of Mars. Mars is going to pass behind the moon and then reappear. So again, related to Artemis. Artemis will be well on its way through its mission at that point on December 7th. And we are going to look at Mars appear from one side to the other. So I can't wait to see that through a telescope. We'll see detail on the moon and Mars at the same time. And then the next day is the close approach of Mars. And we're going to cover that event as well, when the Mars is the closest it can be to the Earth, and we can observe it in a telescope at great detail. So lots to see there. Let's see, checking the comments here. Oh, of course, yeah, thanks for tuning in, Stacy. I'm glad you stuck with us and watched the launch of Artemis. Linda has an interesting suggestion here. Check out Arthur C. Clarke's Earthlight from 1955, a lunar colony and telescope made of hexagonal sections inside a crater to keep cold temp. Oh, that'd be pretty cool. In the same vein of James Webb, right? They have that out well beyond the Earth. They have a sun shield to keep it cold, and it's made of those hexagonal mirrors. But this one would be made in a crater on the moon, so it would be huge, and you'd have similar benefits to that. I'll look that up, Linda. Thanks for the suggestion. Then Barry also suggests Stellarium. Now, yep, Stellarium is one we use all the time, both on a desktop and on a smartphone. It's available there as well on iOS or Android. So go to stellarium.org if you want to try using Stellarium. Definitely a valuable application. Works on Chromebooks too. If you only have a web browser, you can use that as well with Stellarium. Okay, looks like that does wrap up our comments for today. So again, I just want to thank everyone for tuning in this evening. We stuck with it, and we got a launch, and it was great to see. And this really is a massive historic moment for space exploration around the world. It's going to be great to see where the Artemis program goes from here as they start with the next Artemis mission. Artemis II is a crewed mission with an astronaut. They're going to launch astronauts to the moon with Artemis II, potentially in 2024. And then maybe 2025, 26, they'll actually land on the moon. So I can't wait to see this play out. And again, thanks for tuning in. I'm going to bring up our closeout reel, the thanks for watching, and we will wrap up the stream. So we'll see you again next time, maybe this Friday, or maybe on the next Night Sky Live. Thanks for watching, everyone. We'll see you next time.